Hey, hello there. Today's Leetcoding challenge question is called sort colors. We have an array of n objects. They have three different colors, red, white, and blue. We want to sort them in place such that the object of the same color will be together. So the order is red, white, and blue. It just so happened that we use integer numbers 0, 1, 2 to represent red, white, and blue. So the question becomes sort the array of integers in their increasing order. So since that it becomes a straight up or sorting problem, we are not supposed to use the library sorting function. And also here doing the follow-up, it tells us we should aim at a one-pass algorithm that uses only constant space. So just sorting is not enough. We have to be more efficient and also use not a lot of extra space. So what kind of algorithm, sorting algorithm that uses only constant space? Something like a bubble sort or selection sort, where in bubble sort we iteratively finding the largest one and push that towards the end. For selection sort, we iteratively finding the smallest and put that into the left. But those are in square time. What kind of a property from this problem that can actually help us to reduce, some sorting algorithm like that into just one pass? The property of this problem is that we only have three different values. So whenever we're looking at the particular value, we don't need to go further to test whether this value we're looking at is the smallest or the largest. For bubble sort, it's sorting adjacent one, trying to always move the largest among the two over there. Also selection sort, we have to do one pass to find the current minimum and put that into the left hand side. But here we know there are only three values, so whatever that value we are looking at, we know whether it's the smallest or the largest or the one in the middle. So what we can do is to keep two swapping locations, one towards the left and one towards the right hand side, and also in middle pointer pointing at the number we're looking at. If it's a 0, we swap with the left. If it's 2, we swap with the right. Otherwise, we would just advance to the next position. Once we meet the right hand side swap location, that means we have 1, 1, 1, 1, 1, 2, 2, 2, 2, 2 connecting to each other. That's the time we're done. So it's one pass, strict one pass, and in constant space using 3 pointers. And we're pretty much effectively doing the bubble sort and selection sort at the same time with the help of the properties of this array. Yeah, so that would be the solution, 3 pointers. Left, right, and middle, which is 0 in the beginning. It's sort of overlapping with the L. So we can actually do 1, right? Yeah, let's try this. So the termination is that we haven't successfully met the starting point of the 2. That's when we're trying to do the elements check. If we are looking at a 0, we try to swap with left. We'll handle how the pointer moves later on. You just try to get the main logic up first. So the 2 swaps. If it's 0, swap with left. If it's 2, swap with right hand side. Anything that's happening in this else clause will be that we are looking at the 1. So if it's a 1, we advance to the next position. We increment the n. Of course, for in either one of these swaps, if we put a 0 towards this the location L is pointing to, we have to increment this. If it's a swap with right hand side, we have decrement R. The only problem is how we update m inside these two things. So if it's a not 0 but it's 2, we will do a swap with the right hand side. So that swap can potentially introduce a 0 at the m's position. So if we don't, so we are not supposed to doing updates of m inside this second branch here. In the next iteration, you will find that we now have a 0 in the m's position. We will do a swap. that's the time we can actually increment n. So the only tricky part in the algorithm is this. So let's see if it works. No, we have a 2 here. What's the problem? Oh, okay. So I should actually, I think I should start with 0. Yeah. Otherwise, this swap can actually put a 2 over here if it's a very initial one. Okay, so I should actually start with 0. Good catch. Test case. Thank you. Yeah. So that's the question today. Yeah, this is the tricky part, and I messed up with this one. Okay.